Alright, hello everyone. Yesterday was pretty bad, but depending on what type of problem we got today, and we'll decide whether we'll redo yesterday or not. Oh, we'll have to redo yesterday for sure. I thought about this again. I feel like it's not that hard. Seriously, it's not that hard. I don't know. It's just, things happen. Snake and ladder. N by n board cells are labeled 1 to n squared in Postrophaden style, starting from the bottom left. This way, right? It's starting with 1. Each move starting from square current to the following. Choose a destination square next with a ladder with a label in the range. Current plus 1. And minimum current plus 6 and n squared. So 1 or 6. Either move 1 or move 6. This choice simulates the result of a straight 6-sided die roll. If next has a snake or a ladder, you must move to the destination of that snake or ladder, otherwise you move to next. The game ends when you reach square here. Here. A board square on row R and column C has a snake or ladder if it's not equal to -1. The destination of that snake or ladder is board of this. Square 1 and n squared are not the starting points of any. Hold on. I don't understand this sentence. It says a board square on row RC has a snake or ladder if it's not equal to -1. Okay. And the destination of that snake or ladder is, oh, this value tells you the destination. Okay. Now that you only take a snake or ladder at most once per dice roll if the destination of a snake or ladder is the start of another snake or ladder. You do not follow the subsequent snake or ladder. For example, suppose the board is this, and on the first move your destination squared is 2. You follow the ladder. Okay, let's draw it out. Right. So basically it's 1, 2, 3, 4. And then this tells you snakes go to 3, this snakes go to 4. So suppose you first row go to 2, you follow to 3, but do not follow to 4. Return the least number of dice rolls required to reach. The least number of dice rolls basically is just to find the optimal to reach there. For example, I can say I do this, boom, come in here. Right, and do this, boom, come here, and I do this. So I do 1 row, 2 row, 3 row. I can give 3. Wait, if 4 is start at square 1. Oh, that's square 2. So that's 1 row. And decide to move to 7. 17. Wait, hold on. What's the rule again? Then you decide to move to 17. I must take the 13. It has to move to 14. And take like 35. Oh, and then move here to end the game. But why don't we go from 15 to 14? I don't understand. Or do you have to go through all the snake letters? If next has, yeah, why can't I just go? Oh, because it keep increasing. Ah, dummy. Yeah, that's why it keeps increasing. So it keeps going that way. So that's the most it can do. Like if you want to go here, you have to go this way. Boom. Then go here. Go here. Then go here. Ah, now I see. Okay. All right. That's pretty straightforward, I think. DP-ish. Like, area 36, then it's 0, right? You know, actually, maybe we can try drawing it out. Might as well. So we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is, you take 0. This take 1. This take 1 row. This take 1 row, because I can move plus 6, right? So when you are here, that's still 1 move. It's all 1 move. Okay, so now you are 30. Right. How do you decide? You have to go this way. Plus 6. There's still 1 move. From 30, there's still 1 move. Here, well, there's no chance, right? You don't see any chance. Like within here, everybody is the same. So this is also, and then so I want a minimum within the 30, 31, 33, 33, 34, 35. So like the rolling window, right, of 6, the smallest is 1, so this is going to be 2, right? So here is the same, so it's 28 plus 6 is 34, right? 34. So we try to see, yeah, so this is 2 and this is 2, and here, right, this is not. So I have 2 options, right? Because if I'm landing here, I have 2 options. I either because I'm starting from here, right? So I'm just taking, I just come here. So there are two options. One is if I take the snake. If I take the snake, I will go here. So if I take the snake, that's a 1. Don't take the snake, I do 32, right? So 32. So we find the smallest, so that is 2. Right, take the snake, not take the snake. Okay, here. Right, so you look through, you have a snake. So you can decide, if I take the snake, that's 2. If I don't take the snake, that's also 2. Because this plus 6, yeah, that's also snake. So here, right, so we go through this. If I take the snake, so yeah, so if I go here, take the snake as 3. Now take the snake as 3. Take the snake as 2. Now take it. So that's now 2. And then, or now we go here, that's only 3. So this will be 2. Take the snake will be 2. Not take the snake, it'll be 3. Actually, no. 1, 2, 3, 4, 5, 6 is also 2. This one. So I can take the snake, directly. So I find, so that's 2. Take the snake will be 2. Or I don't take the snake. I don't take it, and then I find the next one. That's 3. So it will be 2. And then this will be 3. The 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 2 is 3. Right? So take is 3. I'll take is 3. 1, 2, 3, 4. And actually take is 2. Now take 1, 2, 3, 4, 5, 6 is 3. Take it 1, 2, 3, 4, 5. Now take it is 3. Next, take it 1, 2, 3, 4, 5, 6. Now take it 1, 2, 3, 4. Yeah. Take it 1, 2, 3, 4, 5, 6. Now take it is also 3. Right? Ting. Take it 1, 2, 3, 4, 5. Yeah, it's gonna be 3. Now take it 1, 2, 3, 4, 5, 6. Take it. Now take it 1, 2, 3, 4, 5, 6. It'll be 4. Take it. Now take it. take it, and now take it. Right, 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5, 6. Okay, so now here. What's 14 like? Oh, wait a second. You can only do it if you're at a head. So these in here, they don't count. Oh, Lord. I have to redo it. But honestly, I don't even think you need this. You can just go like simple. 36 is 0. Right, 35 is actually also, it doesn't have a destination, right? So 35, I just look, so I'll be 1, 34, 1, 33, 1, 32, 1, 31, 1, 30, 1, 2, 3, 4, 5, 6, right? That's 1. 29, 2, 28, 2, 27, 2, 26, still 2, 25, still 2, 24, still 2, 23, that's 3, 22, 3, 21, 3, 20, 3, 19, is 3, 18, is 3, 17. Okay, 17. 17 can go to 13. Oh, but we haven't done 13 yet. Oh, snake is to go back. So 17, we basically have unknown. Use a snake, unknown. Not use a snake, plus 6, 23. Oh, it's all 3, so it'll be 4. Right. 16. 16, not the same. We have unknown, or 4. 15. 15 is also not sure, so it'll be unknown or 4. 14. So 14 we can choose take the letter, right? Take the letter, and then 14 and take the letter. So we go here, so we need 1. So for take the letter is actually go 1. Now take the letter as 4. Now it's 13. I can choose to take the letter. So yeah, because I go here, I see 2 options. So if I take the letter, that's gonna be 2. Okay, so I take the letter, I don't know what this is. Right, I don't know what this is. I don't know how to reconcile this. but I don't know what this one is. Because you're going back, right? So if there is no letter in between, then it's not worth it. Right? If there's no letter in between, you cannot do any jump, so you have to go back, right? So if we go back, then it has to have some letter in between. And from this perspective, all these unknowns are required is going back. So if it's going back, so if you go something, then you see some is go back, right? If you see something that's go back, then you say, yeah, it's probably not a good idea. Because it will go back to where you are. Ladder you to go forward is always a better strategy. Go back is a bad strategy. So if we have something and it goes back, right? And then we go through everybody, and then everyone will have a chance to take it. So I should just go down to that. And I keep filling everything, and then it's like you're 14. You can also choose to go 17 and then go back. Or we don't consider snake initially. We consider just the ladder, because the ladder is easier, right? So if we don't consider snake, the snake goes backwards. So if I don't consider snake, then that's that, right? And then 14 will be, yeah, if we don't consider snake, 14 will be 2 or 4. Right, 13 will be, so you go forward to 14. So you go 14, so it's going to be 3 or 4. Actually, no, because you go to 14. 14 is 1. 14 is 1. So it's a 2. Alright, 12. Yeah, so you go 1, 2, 3, 4, 5, 6. And that's a 3 as well. So it'll be 4, and then this will be 2. Alright, 11. Same thing. 1, 2, 3, 4, 5, 6. 10. 2, 3, 4. 6. So it's still 2. 9. Still 2. 5. 8. 6. I think it's the last one. 5. 1, 2, 3, 4, 5, 6. We have 3, but this has to be 6. 1, 2, 3, 4, 5, 6. Right. 4. I think so. 3. 1, 2, 3, 4, 5, 6. Yeah. 3. 1, 2, 3, 4, 5, 6. Okay. 3, 6, 2. 1, 2, 3, 4, 5, 6. And 6. 1. 1, 2, 3, 4, 5, 6. 4. I think this is still 6. Then voila, you got 4. That's without considering the so basically you will but 2 is different because 2 can go to 15. So 2, if I don't do anything, I'll do 1, 2, 3, 4, 5, 6. Yeah, the smallest will be 3. Yeah, the 2 is actually not right. The 2, because I go straight to 15 if I take it. Right? I should go to 15. And from 15, I'll take 4. So let's take them longer. Five steps. So yeah, so we take the 3 steps. Okay, now we have to handle the reverse. Do we do it 2 rounds? Yeah, I'm falling asleep. Yeah, I think it's reasonable. If you go back, you'll have to reanalyze. Right, so we have a chance to go, right, so it's an unknown, unknown, unknown. I think that's like, we can also go on unknown, right, all the way to 11, right? Then we'll go through the thing again. Find something we have unknown, and I see a link to 13, and 13 is 2. So this is 2. $16. Yeah, we'll go back, we'll just keep going then. Or even better, we find out how moving forward goes, right? And then we try to see if moving back can bring you benefit. So we're specifically looking at 17. We're looking at the list of moving backwards, right? So from this, we know if we moving forward from this towards the end, it's going to be a certain amount. And we say we start from here and then move back to 13, right? And that directly will not make a difference. Because 13, it's the same, right? It's the same. Which means at 17, if you go to 13, You don't get a benefit. Actually, you do. Because at 13, you get 2, right? So at 17, currently is 4. So if I go to 13, and then that trip is, so I got a 2 with the using, right? I got a 2. And then it's using the thing. And then this, I go and I got 3, and this, I got 3, this, I go, it didn't change, so this stay as 1, right? The maximum stay as 1 is with the yeah, so with the ladder. So in this case, do I still record? Like without ladder at 14, right? Without ladder is 4, with ladder is 1, and with snake, still, I think we do the ladder first. Okay. Once we do the ladder, we can try to see if snake can make things even better. But how? I don't know. I'm gonna check the answer. I don't know how to do this. Let's see. BFS using just the labels. Protocol necessary. Of course, we must create a mapping between the labels and the board values. But after that, we can very easily move forward in labels. I have no idea what I just read. I think I do the board. Okay, so this is the, at each position, I need to know what it is. Okay, I know what this one, I know what this part does. And then what? Yeah, I know the row and column not necessary. So we just BFS this thing. That is true, because you can go 6 positions, right? So you have the next possible. Ah, I think I know what this is about. So, not really DP or anything. What we're saying is we grab all the positions, right? And then we start from 1. And then, no, we start from, because the first you have 6. 1, you can start from 1. First row, right? 1 to 6. You have 1 to 6. That's your thing. And then from there, you have for each one, but you have to you can move forward, right? That's always a next position, or you can jump, right? Or you can jump, but we don't allow continuous jump, which means when you jump, you have to carry the state, whether you arrive there through jumping, right? Whether you arrive there through jumping. I don't know if I do anything like that. I just do this. What's this logic? Yeah, I'll have the next label. If next label is equal to target, what the hell is target? Okay, if next label, so which means we reach it, then steps plus equal plus 1, right? That means we already reach it. If next label is smaller than 0 and it's not visited, which means it's just unvisited, well visited, right? Or if the next label is equal to target, M is mapping, right? M is mapping, and this basically says I mean, I don't have to do this because it's the next round. I think we'll hit it as well because the steps doesn't go. I know this is just handle a thing like you hit something and it directly goes to the destination, right? And then yes, you're good because you move on to the next one. Now it is plus 1. Or if the next one is not visited, but if the one is already visited, then you don't put it in. So how do you prevent double jumping then? So double jumping is when you hit something, then you jump, right? Yeah, it's like not visited, so you're putting here. But then the next round, yeah, this one doesn't prevent double jump. How is this correct then? There's no need to consider whether the move to the next cell is a jump or not. When we visit a cell, it is guaranteed to be a non-jumping cell, regardless of its board values. It's because we already handle the jumping during the cell visit, such that the cells pushed to the view is always a non-jumping cell. The cell already pushed to the queue is always a non-jumping cell. What does that mean? When we visit a cell, it is guaranteed to be a non-jumping cell. I don't understand. You're visiting this, right? So basically, if I have, let's say, 2 to 14, right? So I say next label is here. So M next is this, is now visited. So I push this to visit, right? So the next round, this one will come up. And oh, I see, because you always jump forward. Oh, that's a piece of work. Wow, that is a piece of work. Yeah, you always jump forward. It's guaranteed from there. So every time you land on a cell, when you visit a cell, right, it's guaranteed that you don't jump from this cell, because you handle the jumping when you move 6 positions forward, right? You handle the jumping when you move 6 positions forward, and then you jump, right? But then when you land, you don't jump again. Pretty smart. All right, that will be it for today. I think I'll implement it tomorrow, so at least we get some practice in. But damn, I feel this one's pretty hard. I don't think did I solve it last time? Yeah, I don't think I solved it last time.